All right, let's talk about density. Density is the amount of matter per unit of volume. In other words, density is equal to mass divided by volume, or D equals mv. And you can always remember this because the world's densest people work at the DMV. Yes? Density is a physical property of a substance. The units for density depends upon the state of the substance. Things in the solid state usually express their density in units of grams per cubic centimeter. Things in the liquid state express their density in grams per milliliter. Things in the gas phase, grams per liter. Notice that you can directly compare the density of a solid to the density of liquid, because a cubic centimeter is the same size as a milliliter, right? 1 cubic centimeter equals 1 milliliter. So you can directly compare a solid's density to a liquid's density. A gas, however, is much, much less dense than either a solid or a liquid, so rather than use milliliters or cubic centimeters, we use liters. 1,000 times more volume when we're comparing our density of a gas. Why don't you write down mel for me? Write down mel for me. M-E-L, mel. M-E-L, mel. Here are some densities of some common substances. Let's take a look here. And let's start by looking at the density of water. The density of water is 1 gram per cubic centimeter. You have to memorize that. A lot of what we do this semester will depend on you remembering that 1 gram of water has a mass of 1 cubic centimeter. Or to put it another way, we would say that water has a density of 1 gram per milliliter, right? Same thing. You need to remember that fact. You'll be doing lots of conversions, particularly in lab, where you'll be measuring volume, but you'll suddenly be working with mass units just because the density of the water is so close to 1 that they just use that as an assumed or understood. Let's take a look at some other liquids here. We have ethanol. Ethanol has a density of 0.789 grams. Gasoline, 0.737 grams. So those are our other liquids. And we've got some helium, 0.1785, and air, 1.225 grams. By the way, what do you do with a sick chemist? If you can't helium, you bury 'em. All right, as long as we're looking at these densities, now's a perfect time to talk about one of the things we know about a substance by looking at its density, or something we can know by looking at two substances' densities. Have you ever stopped to consider why it is that helium balloons go up? Why do helium balloons go up? What's the density of helium? What's the density of air? Helium's density is less than the density of air. And anything that is less dense will float on anything that is more dense. A classic classroom demonstration involves pouring 3 liquids into a graduated cylinder. Pouring them very carefully and in order of least dense to most dense into the cylinder can allow the 3 liquids to remain separate. The most dense liquid will always be on the bottom, followed by the next most dense, followed by the least dense. In my pretend highly skilled artwork presentation of this experiment, we can see that ethanol is floating on water, which is floating on glycol. Less dense floats on more dense. Is the horse dead yet? Let's work some math. But before we do some math, why don't you write down Jane? J-A-N-E. Write down Jane. J-A-N-E. Alright, if ethanol has a density of 0.789 grams per milliliter, what is the mass of 42 milliliters of ethanol? Gee whiz, if only we knew how to work this. Wait, we do, because guess what we hear there? Chemistry cat, can you tell me what a conversion is? Oh yeah, right? What happens when we say the units of density? 0.789 grams per milliliter. It turns out that density is a conversion factor between mass and volume. In other words, 0.789 grams of ethanol is equal to 1 milliliter of ethanol. So density provides us a way of going from mass to volume. So when we work this problem, having identified density as a conversion factor, that leaves us only one other number to work our problem with. That of the 42 milliliters. If I have 42 milliliters, and I don't want to have 42 milliliters, I'm going to place milliliters down here where they'll cancel out. I want units of mass. Do I know a relationship between units of mass and volume? Yeah, that's what my density tells me. 1 milliliter is equivalent to 0.789 grams. Multiply everything on top, divide through by everything on the bottom, and you get 33.138 as the calculator lie. We've got 1, 2, 3 sig figs there, 1, 2, 3 sig figs there, 1, 2, 3 sig figs. So 33.1 grams of ethanol would be the mass of 42 milliliters of ethanol. Chemistry's easy, life is hard, right? What volume in microliters would 6.24 times 10 to the negative 8th of helium have? The density of helium is 0.1785 grams per liter. Well, once again we have density. And density always provides us with a unit conversion. So when we're writing what we know that 0.1785 grams equals 1 liter, right? Grams per liter for helium since it's a gas. So that's a unit conversion. The only other number in our problem is 6.24 times 10 to the negative 8th grams. I have units of grams. Do I want units of grams? No, I do not. So I place grams where they cancel out. I know a relationship between grams and liters. So I place liters where I want them, up top, and grams where they cancel out. So my grams have canceled out. Keep the numbers with their units. 0.1785 grams to 1 liter. I now have units of liters. I don't want units of liters They're asking for volume in microliters. I know from my memorization that 1 microliter is 10 to the negative 6 liters. I place liters where they cancel out. I place microliters where they'll be left. 1 microliter, 10 to the negative 6 liters. I multiply everything on top, divide through by everything on the bottom, and that gives me a calculator lie of 0.34957981 micrograms. If I do my sig fig analysis, I have 3 sig figs there, 4 sig figs there. This is exact. My least number of sig figs is my 3. 1, 2, 3. Round on the basis of the 5 and the 5 alone. That makes my 9 a 10 and my 4 a 5. So my final answer, Alex, is 0.350 microliters. Bum, bum, bum. If you're taking the lab portion of this class, you'll probably determine the density of an unknown object using a technique known as water displacement. In this technique, you start off with a graduated cylinder and you'll fill that graduated cylinder partially with some water. And you'll record the volume of that water. Next, what you'll do is you'll take an object whose density you want to determine, you won't know the object's density, but because you have access to a balance in lab, you'll know its mass. You'll take the unknown object, whose mass you know, and you'll place it into the graduated cylinder. Now this unknown object here, it's a circle, right? So would it be easy for us to measure its volume? No, it's really hard to measure circumferences, or matter of fact, it's not even a circle. It's something really unusual almost. It's weird, like a little mouse-shaped thing or something. It's got an irregular shape. So we're dropping it in this water to determine its volume. So we drop it into our graduated cylinder. And you're seeing what happened to my career as a comic book artist. It went nowhere. I drop my irregular object into my graduated cylinder, and it sinks to the bottom. What do you think happens to the water level in the graduated cylinder? The water level rises. And when I read the volume of the water with the object in it, I discover that the volume is now 51.5 milliliters. I can obtain the volume of my unknown object by subtracting the difference in height. The difference in height in the water will be equal to the volume of my unknown object. Now this technique only works if the object is more dense than water. If it's less dense than water, we have to play with Archimedes' principle a slightly different way. But we'll leave that to the physicists. For our purposes, our object sinks and causes our water level to rise, and the volume of our object will be equal to the difference in the volume after it's dropped in minus the volume before it's dropped in, So the volume of our object would be 51.5 minus 40.2, or 11.3 milliliters is the volume of our object. If we have a volume and we know its mass, it's going to be really easy to calculate the density. Density equals mass times volume. So 15.3866 grams divided by 11.3 milliliters. And that gives me 1.36164618 is my calculator lie. If I look at my measurements, I've got 3 sig figs here. Whoa, 6 sig figs here, and that's very close to the scenario you'll have in the lab. 3 is the least number, 1, 2, 3, round on the basis of that. So that gives me a final answer for the density of my object of 1.36 grams per milliliter. And that's how you do that. And you will be asked to do that in some of your homework problems, as well as those of you who are taking lab will be asked to do it. It's so easy, though, that WASH could do it. Why don't you write down WASH? W-A-S-H. WASH. All right, let's work another example. Matter of fact, since you saw me work it in detail on the last one, why don't you actually pause me here and see if you can work this before I spoil your fun. Did you pause me? No, of course you didn't. Oh well, I asked you to. But at any rate, so let's work this. 42.3213 grams of an unknown object is dropped in a graduated cylinder containing 29.9 milliliters of water. After the object was placed in the graduated cylinder, the water level read 44.4 milliliters. What is the density of the unknown object? To solve for density, I need a mass and a volume. The problem gave me the mass with no trouble. Whoops. But apparently I have trouble writing it. What it didn't give me directly a volume. So I'm going to have to do my water level difference to calculate my volume. So I take that final water level and I subtract the initial water level, and that gives me 14.5 milliliters. So now I have a volume to put in. Mass divided by volume. And that gives me a calculator lie of 2.918710345 grams per milliliter. But when I do my sig fig analysis, I've got 6 there, 3 there, so my final answer should have 3, 1, 2, 3. So my final answer is 2.91 grams per milliliter. But you beat me to that because you had paused me so that you could work it in advance and then just double check me. Alright, because density is way, way too easy, we had to mess it up by coming up with a new term for it essentially. And that's specific gravity. Specific gravity is the ratio of a substance's density to the density of water. Now, let's look at what we mean when we talk about specific gravity. If the density of ethanol is 0.789 grams per milliliter is the density of ethanol, what would the specific gravity be? Well, it's the ratio of ethanol's density to the density of water. And the density of water, you'll remember, I told you to memorize, is 0.1 grams per milliliter. Well, you divide any number by itself and you get the number. Well, you divide any number by 1 and you get the number. Then look at what happens to our units. Grams cancel out, inverse milliliters cancel out. So the units on specific gravity are none. Specific gravity is unitless. Are you catching on to what happens here? The density of ethanol is 0.89 grams per milliliter. The specific gravity, 0.89. Specific gravity is simply density with no units. Whenever you see specific gravity, you assume the units are grams per milliliter. It's that simple. Let's work another example. Gasoline has a specific gravity of 0.737. What volume of gasoline would have a mass of 8.8 kilograms? State your answer in liters. We've got two numbers in our problem. That means one of them has to be a unit conversion. In this case, chemistry can't help us out because the evil specific gravity has lopped off the per units. We've cut off our cat's nose practically. But whenever you see specific gravity, drop in those units. If it has a specific gravity of 0.737, then it has a density of 0.737 grams per milliliter, which means we have a conversion factor of that. That leaves us one number to start our line with, 8.8 kilograms. Now, our first step is going to have to be getting rid of those kilograms. What do I know about kilograms? I know that 1 kilogram is 1,000 grams. So now I've gotten rid of kilograms and I have units of grams. I don't want units of grams though. So now I'm going to have to get rid of my grams. The thing I know about grams is the relationship to milliliters. I know that 0.737 grams of gasoline is equal to 1 milliliter of gasoline. Now, we're not asked to solve for milliliters of gasoline, we're asked to solve for liters. So I'm going to have to get rid of my milliliters and go to liters. And I know that 1 milliliter is 10 to the negative third liters. And hey, now I have the unit that they're asking for, so I just need to multiply everything on top, divide through by everything on the bottom. And this is just a casual observation. See how far we can get in working a problem simply by taking those units that we don't want and continually getting rid of them until we get to something we do want. It's kind of like dating, right? You keep dating new people and getting rid of them until you finally find the one you want. But at any rate, Dr. Kelly's philosophical moment for the day. And that gives me a calculator lie of 11.94029851. However, when I look at my sig figs, I have 2 sig figs there, 3 sig figs there, so my answer should have 2, 1, 2. Round on the basis of the 9. So my final answer is 12. It is 12 liters. Why don't you write down river? Write down river. R-I-V-E-R. Write down river. There are 2 really cool characters in science fiction named River.